Hello. In these last two classes, we will conclude the study of stochastic systems. Over the last classes, we studied their properties, the way they behave, and we saw how we can identify models for systems of this type. Now, we will take a look at controller design. You will see that system identification is always very present in the design of controllers for stochastic systems, in particular in adaptive control.
In what follows, we assume that the system we want to control is an Armax. Consequently, the output depends on two things. One of them is a known input, which, since we are designing a control system, has to be a manipulated input, one which we can set to a desired value. The output is related to this known manipulated input by this transfer function that may include a direct delay from u to y. If there is no delay, of course, then d is equal to 0. The other thing output y depends on is a noise, which I will here represent by e of error, as we have been doing. This is the transfer function relating e with y, and of course, since this is an Armax, the denominators are the same. So this output y can be written as a function of e and u as follows. Or we may write the relation from this input to the output in the following manner. Since we have here a delay, u of t will only affect y at time instant t plus d. So we write here the error or noise affecting this output at the same time instant we have here, and now the delay is represented by this difference from this time instant to this one. We will control this output in closed loop. This is consequently the reference, and this is the error of the closed loop. Since I have used E to denote this noise or error, closed loop error will be denoted by an epsilon. I have assumed a unit feedback branch, that is to say, a perfect sensor, in this block diagram. Finally, this is the controller that we want to determine. We will now consider two separate cases. In the first case, this reference is constant. If the reference is constant with time, we can assume without loss of generality that it is in fact 0. This is because if the reference is constant, by means of a variable change, I can make it to be constant and equal to 0. So this will be the first case to consider, the case in which the controller is known as a regulator. Later on, we will then consider the case in which the reference changes with time and is no longer constant.